Hi folks, it's Christina from Kenyatta College in Redwood City again, adding to our math video library. This one is going to be on percents. If you have any questions, comments, concerns, or requests for certain problems in a Kenyatta College math book to be put into a video format, go ahead and email me, Christina_KenyattaTutoring@yahoo.com, and we're going to move straight along to our percents. Okay. The big thing to remember about percents is that percent means of each 100. Whatever percent you are given is really just a fraction over 100, and in fact, that is how you convert a percent to a fraction and then end up converting it to a decimal. Everyone ends up finding their own way through all of this, but this is how I find my way through it. Okay, so the first thing we're going to do is changing percents to fractions. So we said we're going to divide by 100. So changing 35% into a fraction. Yeah, this is a fraction. I give you that. But we need to simplify. Always, always simplify, unless it says do not simplify. So we know that 5 is our GCF, our greatest common factor of 35 and 100. That simplifies to 7 over 20. So that is the simplified fraction of 35%. The next problem, example, is changing 164% into a fraction. And this is an interesting problem because almost everybody thinks that percentages have to be less than 100 because 100 is equivalent, 100% is equivalent to the number 1. But really, we can get more than 100% of stuff. It may not seem like it, especially when it comes to our, take home, okay? Anyway, change 164% into a fraction. Notice that this percent is greater than 100%, and that should tell you that your final fraction needs to be greater than 1. So if it were 100%, your final fraction would just be 1. It's a whole number. But anything over 100%, it better be bigger than 1 when you end up with your answer, both decimal and fraction form. So again, we put 164 over 100, and we start simplifying. First, I'll do it the way most students do it. Divided by 2, divided by 2. We know 2 goes into both of these. Why do we know that? Because 164 and 100 are both even numbers, so they are both divisible by 2. That leaves us with 82, and that leaves us with 50. For those of you who aren't familiar yet, I have this handy-dandy calculator, and we can go 164 divided by 2, and that gets me, lo and behold, 82. But the 82 over 50 can also be reduced. They're both even numbers. They can both be reduced by 2. So 82 divided by 2 is 41. We know that 50 cents divided by 2 is 2 quarters. So our final answer in improper fraction form is 41 over 25. Hopefully by now you're comfortable enough with fractions to know that 41 over 25 is an improper fraction, and therefore it is greater than 1. But we can also convert it to a mixed number. Hopefully you remember how to convert into mixed numbers, but off to the side real quick, we'll just show you. 25 goes into 41 one time. You should know that off the top of your head because 2 quarters makes 50 cents, so only 1 quarter can get into 41 cents. We subtract, and that's 16. This becomes our numerator. This is our remainder, but now it becomes our numerator. This is our denominator. I'm just going to put denom. Okay, and this is our whole number part. So 1 and 16 25ths. Oh, they're both perfect squares too. That's a coincidence completely. So I want to give you a little cheat sheet sort of some of the more common percent fraction conversions you just need to know. And we talked about the 1 equaling 100. 0.75 in decimal format equals 3/4 in fractional format, which equals 75%. 0.5 is equal to 1/2, which is equal to 50%. 0.25 equals 1/4, which is equal to 25%. Now, the last two are a little tricky, and students ask, well, how am I supposed to know that? These are just things you got to know. 0.67 is actually equivalent to 0.66, and then it just repeats on down the line to infinity. That doesn't give us much comfort, but that's just the way it is. That is equivalent to 2/3, and we can do this. 3 goes into 2. How many times? 3 goes into 26 times, it's 18. Look what's happening. There's another 2. 3 goes into 26 times, that's 18. But look what's happening. So you can do this a few times, but you're going to learn that it's just 0.67 rounded. And and that also is equivalent to 67% rounded, or 66 2/3%. That's actually an exact answer, the 2/3. This is rounded. Okay, 0.33 is the same thing. It's equivalent to 1/3. And you notice 0.33 is about half of 0.67, so 1/3 is, half of that. 33%, or 33 1/3%. So there you go. There's some quickies for you to just know. But if you do the long division, you can figure it out. Okay, so we're going to move on. Changing a percent to an equivalent decimal. So we do the first step that we did for fractions. We divide by 100. Instead of simplifying that, we're just going to do the division and then drop the percent sign. So here we have a problem. Change 15% to a decimal. 15% over 100. Do some long division. 15, 100 here, 15 there. Remember, when doing long division, you drop this and you put a box around it. That's why the 15 is inside the box. Don't forget, when doing long division, that 100 doesn't go into 1, so you put a little 0. 100 doesn't go into 15, so you put a little 0. 100 does go into 150, so that's where you start your answer. Your final answer is 0.15, and I've done the long division here to sort of show you how to do that. A lot of students, though, they don't put the zeros right here, and then they miss the decimal, and all of a sudden they get 15, and it's not 15, it's 0.15, okay? And we're going to show you a little bit later what that means with the whole decimal moving around. So here's another one. Change 143% to a decimal. So just as I did with fractions, I want to show you something that has more than 100% in it. So you put 143% over 100. You drop the percent sign. Again, 100 goes into 143. This time, we do it a little differently because you notice this goes there. So 100 doesn't go into 1, 0. 100 doesn't go into 14, 0. But 100 goes into 143. Put a big old 1 there. Then you start doing your whole long division process. You end up with 1.43. Again, notice there's no percent here. There's no percent here because you have changed it to an equivalent decimal. Okay, now we're going to go a little bit backwards. How about changing decimals to equivalent percentages? So what you should notice is that percents always look bigger than their equivalent decimals. They are in fact equivalent though. For example, 3% equals 0.03, and you sit there and you ask yourself, well, which one looks bigger, the whole number 3 or 0.03? That's how you know where to throw the percent sign or not to throw the percent sign. So how do we get there? When converting from percents to decimals, we divide it by 100. So to convert from when converting from decimals to percents, and if I can get in here, that would be good. Bear with me. From decimals to percents, we will do the opposite, and instead of dividing by 100 as we did before, we're going to multiply by 100. But we also need to add the percent sign when doing that. So changing 0.38 to a percent, 0.382%, we multiply by 100. 0.38 times 100. I did the long part out here. You're going to get, this moved down a little bit, you're going to get the number 38. Okay, but let's do it with our handy dandy calculator so that you guys see what this looks like. 0.38 times 100. Oh, look at that, it gives me 38. But don't forget, you got to add this little handy dandy percent sign right here, okay? So, converting from percent to decimal, you drop the percent. When converting from decimal to percent, you have to add the percent. Otherwise, I don't know what that is. It looks like just the number 38 to me. So we're going to change 1.19 to a percent. Okay. Remember, anything more than 1 is going to be more than 100%. So we take the 1.19, which doesn't look like 1.19, so I'll make sure I add a little decimal there, times by 100. I did the long multiplication process out, and that got me to 119%. One thing I want to point out is there's 2 decimal places here, 1, 2. There's no decimal places here. It's really kind of hiding over here impliedly. So down here there better be 2 decimal places in your final answer. That's how I get to the 119%. And again, we added the percent sign. So we're going to just briefly talk about what's really happening when we convert decimals to percents and percents to decimals. You'll notice that we move the decimal places to the right when converting from a decimal to a percent. We multiply 0.32 by 100. Okay, it's the same thing as moving it to the right twice. That's why the 32 looks bigger than the 0.32. Okay, that's how I know that this is the percent and that this is the decimal. However, when we convert from a percent to a decimal, we move the decimal places to the left 2 spaces, equivalent to dividing by 100. You're going to notice 53, the whole number, looks bigger than 0.53. That's how I know the percent goes here. And most students get confused. They say, well, how do I know when to multiply by 100 and when to divide by 100? So I sort of say, remember that the percent always has to look bigger by 2 decimal places. So 32% looks bigger than 0.32 by 2 decimal places, and 0.53 looks smaller than 53% by 2 decimal places. So long as you remember which one should look bigger, that might give you an idea of in which direction you should be going. So we're going to change a fraction to a percent. It is the same as changing a decimal to a percent. Multiply by 100 and add a percent sign. So, example, 1/4 to a percent. Let's change that. So I've got the 1/4. I'm multiplying by 100 as instructed. If you multiply straight across without doing any cross canceling to get 100 over 4, you should know that there are 4 quarters in 100. That leaves us with 25%. Okay? And this is one of those that was on the list, the 1/4, that you should just know is 25%. Here I'm going to do a little bit cross canceling. Change 3/20ths to a percent. So I started out with 3/20ths. I'm multiplying by 100 as instructed, and then I think, oh, well, let me just simplify this earlier in the process rather than later. 20 goes into 20 one time, 20 goes into 5, 20 goes into 100 5 times. What's left? We've got 3 over 1 times 5, which we know is 15%. We add the percent sign. Don't forget to add the percent sign. So now we're back to the common thing that I'm trying to drill into you about numbers that are greater than 1. Change 1 4/5 to a percent. So, quick question, should the percent be bigger or smaller than 100? Since we've got a number bigger than 1, our percent better be bigger than 100. So 1 4/5 times 100, switch this into an improper fraction. 9/5 times 100, I'm going to do a little cross multiplying. I divided 5 by 5 and got 1. I divided 100 by 5 and I got 20. That leaves me with 9 over 1 times 20. That leaves me with 180%. Note that if your decimal or fraction is more than 1, then your percent should be greater than 100. I've mentioned that a few times. So we've got this one more, and then we're going to end this quick video. Or not so quick, as the case may be. Anyway, here's some percent word problems. Well, here's one anyway for this video. How do you figure out your percent on a test? So, for some of you, your tests are only 20 questions, and so you get 15 out of 20 of them correct, but you need an 80% to pass the test. Most of you are saying 80%. Why do I need 80%? Well, if you're familiar with the 811 program here, you'd sort of know why, but let's just say, hypothetically, that your teacher has required 80% to pass the exam. First, recall that with fractions, the whole part goes in the denominator and part of the whole goes in the numerator. So 15 out of 20 is equivalent to 15/20ths. So we take 15/20ths, we do our process, multiply that by 100, we do our cross canceling. 20 divided by 20 is 1, 100 divided by 20 is 5. That leaves us with 15 over 1 times 5. 15 times 5 is 75. Well, 75% is less than 80%, so guess what? You didn't pass. And for those of you who don't trust me, let's do 15 times 5. 75. Let's see which one's bigger. 80 minus 75. You missed it by 5 percentage points, right? But you should have been able to do that in your head. Anyway, that is our first video, and there will be one more that has some more difficult problems to do with markup and discount and such in the next video. So this is the end of the percents video number 1. Again, if you have any questions, comments, concerns, or suggestions on future videos that deal with math classes here at Kenyatta College, go ahead and email me, Christina_KenyattaTutoring@yahoo.com. And yes, Kenyatta has this little Enye here, but I don't think you need it for the email address. Thanks, and we'll see you in the next video.